Hello again, year sevens. We're back. First, we're going to do a little review of some algebra we did earlier this year, expanding brackets. So this first term here I have is 3 times the bracket x plus 2. So we need to make sure that the 3 multiplies everything inside the bracket. I have to do 3 times x and 3 times plus 2. 3 times x is 3x, 3 plus 2 is 6. The next example, I have a 2 out in front of the bracket. Remember, with no sign, this really means 2 times whatever is in the bracket. So I need to do 2 times 4 and 2 times, that's not an x, that's a negative x. So 2 times 4 is 8, 2 times negative x is minus 2x. It's just another way of writing an expression. Sometimes we're going to prefer it with the brackets, sometimes we're going to prefer it without the brackets. We need to be able to write it both ways. Okay, I want you to very quickly, in your books, copy down the original, expand the brackets, and then pause the video first before you do that, and then expand the brackets, and then continue on to see how you did. Okay, the first term I'm going to do 5 times x, which is 5x, and 5 times positive 5, which is 25. The next term I'm going to do 6 times 3, which is 18, and then the next term is a negative x. 6 times negative x is minus 6x. Okay, same thing, quick example. I need to multiply what's outside. The first expression says 3 times the bracket 2x plus 2. So I have to do what's outside by everything inside. 3 times 2x, 3 times 2. 3 times 2x is 6x, 3 times 2 is 6. The next example, I need to do 2 times 4x, which is 8x. And I need to do 2 times negative 4, which is negative 8. Your turn. Pause the video, expand these, and then start the video to see how you did. Okay, if we do the 5 times 3x first, that's 15x. 5 times positive 5 is 25. The next example, I do 6 times 4x, which is 24x. Remember, we are multiplying, and I'm doing 6 times x minus 3, which is minus 18. Okay, so where are we going to use this? Sometimes when we solve equations, we might want to expand brackets. So if I need to solve this equation, ultimately I am going to need to get rid of the bracket. So the first thing I could do is expand the bracket. 3 times x is 3x, 3 times 8 is 24, and this equals 27. Now this just looks like all the other equations that we've been solving so far. We would take away 24 from both sides. That leaves me with 3x equals 3, and then we divide by 3, and we have our answer x equals 1. We can check it. 3 times 1 plus 8. 1 plus 8 is 9 times 3 is 27, so this works. Now, there's something else we can do. This says 3 times x plus 8. So what we can also do, this time we have 2 choices. I could also divide both sides by 3, because the opposite of multiplying the bracket by 3 is dividing by 3. If I divide the whole left side by 3, divide the whole right side by 3, the 3's cancel. So the left side is simply x plus 8 equals not 27. X plus 8 equals 9, and I take away 8 from both sides, and x equals 1. So notice this way I could either expand the brackets first, or I could divide by 3 first. Either way, I get the same answer. Okay, I want you to go ahead and try this one. Pause the video, try it, and then restart and see how you did. Okay, let's try this both ways. What if I expand the brackets first? I would have 4x plus 24 equals 28. And then I could subtract 24. That would leave me with 4x equals 4. Divide by 4, and x equals 1. Can I divide by 4 first? Sure, I can. If I have 4 times x plus 6 equals 28, I can divide both sides by 4. 4 divided by 4 is 1. So on the left, I just have x plus 6. 28 divided by 4 is 7. And then if I subtract 6, x equals 1, I get the same answer. Either way, it works out the same. So for our next example, how is this one different than the ones we've done before? Have a quick look. Why am I just doing another one? This looks just like the ones we've just done. What's different? Why do we need another example? Well, let's expand the brackets. Let's see what happens here. I get 3x plus 24 equals 29. I'm going to take away 24. That leaves me with 3x equals 5. I'm going to divide by 3, and I'm left with an answer of x equals 5/3. Remember, it's perfectly acceptable to leave it as a simplified improper fraction. Okay, so that seems just what we've done before. What about the other way? What if I want to divide by 3 first? Well, 3 divided by 3 is 1, so on the left side I just have x plus 8. On the right side I have 29 over 3. So I need to take away 8. X equals, now I have to work out what 29 over 3 minus 8 is. I don't really feel like doing that, do we? I mean, 8 is 8. If I wanted to make 8 as a fraction with a denominator of 3, that would be 24 over 3, so I would be subtracting 24 over 3, which gives me the same answer, 5 over 3, but that way was a lot messier. So as you can see, sometimes it's going to be easier to expand the brackets than divide first. My general rule is if you're going to divide by the number in front of the bracket and you're not going to get a whole number on the other side, don't do it. Expand the bracket first. Life will be easier. You try this one, pause the video, try this one, and then see how you did. Okay, so who wanted to divide by 4 first? So if I divide by 4 first, 29 divided by 4, that's not a whole number, so I don't want to do that. I'm going to expand my bracket. 4x plus 24 equals 29. I'm going to take away 24. So 4x equals 5. I'm going to divide by 4. X equals 5/4. Now, you could have divided by 4, and on the right side you would have 29 over 4. On the left side, x plus 6. It's a little bit messier. As long as you keep track of your work, you will end up with the same answer. Okay, I want you to pause the video. I want you to solve these, showing all you're working out in your exercise book. Okay, so on each of these, the first step is, do I want to divide or do I want to expand? Well, I know 4 goes into 64 because 4 goes into 60, so it'll go into 64. So I'm going to divide both sides by 4. And if I do that on the left side, 4 divided by 4 is 1. On the left side, I just have x plus 7. And 4 times 15 is 60. So 4 times 16 must be 64. Take away 7. X equals 9. Okay, the next one, does 6 go into 84? Well, actually, it does. 6 times 12 is 72, and add another 12, so that would be 14. But how about we do expand the brackets on this one? So this one will be 30x minus 54 equals 84. 30x equals 30, and x equals 1. So there was a problem in my working there, wasn't there? When I add 54, 84 plus 54 is 138. So 30x should equal 138. And then I'm going to divide by 30, so I get 138 over 30. Now, this can be simplified. I know 3 goes into both of them, or I can just simply have it first. If I have it first, I get 69 over 15, and then I can divide both of those by 3, so I'm going to get 5, and if I divide 69 by 3, I'm going to get 23, so I get 23 over 5. This is one that I have a feeling life would have been easier if we divided by 6 first. Next one, do I want to multiply or divide? Well, we caused ourselves a problem by expanding last time, so how about we divide this time? 7 goes into minus 35. So 8x minus 1 equals minus 5. I'm going to add 1. 8x equals minus 4. I'm going to divide by 8, x equals minus 1/2. Remember, you can leave your answers as fractions, but they need to be simplified. Okay, on the next one, I notice right away that 3 does not go into 17 on the right side, so I'm going to expand my brackets. It's going to leave me 3x plus 15 equals 17. I'm going to take away 15, so 3x equals 2. So x equals 2/3. Notice again, it's a fraction, but it was very easy to work out because we followed our rules one step at a time. Your work goes down the page. Every problem, my work goes down the page, one step at a time, goes down the page.